Okay, welcome to Chapter 1-2. We are skipping Sections 1-1 due to the fact that it's not needed on the end of course exam. So what we're doing today is Chapter 1-2. A lot of the things we're going to go over today is stuff that you already know how to do, something that you should be expected to know how to do, and in the event that you don't, please do ask and stop. Stop me if you need extra help. So, the first thing you need to know about is real numbers. Now, we've talked about the real numbers several times in here, and the first thing you need to know is how do we write the abbreviation. Remember that was 2 lines down, and then make an R out of it. Now, since it's 2 lines down, make an R out of it, that is any number you can think of in the real numbers world. That's the absolute first thing you need to think about. The next thing is the irrational number system. Remember I gave you this lovely little picture over here, and we're going to talk about that briefly. The irrational number system is the first number system that was created along with the rational number system. And in the irrational number system is any number that you can be expressed that cannot be expressed as a fraction, meaning it's the non-repeating decimals. This is where pi fits in. Okay? Also your square roots. Now, with that said, the next thing you need to worry about is going to be your rational number system. Your rational number system is any number that can be expressed as a fraction. And these numbers are whole numbers, fractions, and terminating decimals and repeating decimals. So that's going to be your 1/2, which is going to be the 0.5. It's also going to be your 1/3, which is going to be your 0.33 repeating. Okay? Those are all going to be your rational number systems. And I didn't tell you this before, but that is going to be a bold-faced Q. That's your rational number system. The next one is going to be your integers, any positive or negative whole number including zeros, and that is going to be your z with the double diagonal. Example of that is -10, -5, 0, -32, positive 5,302. Those are all examples of integers. The next thing is going to be your natural numbers. Your natural numbers are any recounting numbers. Now, obviously, natural numbers, whenever you count, are going to be starting with 1 and not 0. So therefore, we're going to have 1 all the way up to any number that you can think of that is a whole number, not infinity. However, it goes all the way up to infinity, which is why I'm leaving that infinity sign there. Now, this is review for you. We've already talked about that whenever we talked about the integers. Now, I gave you this lovely little picture, and these were the stackable cups that I talked about at the beginning of the year. Now, with that said, remember I talked about if you are a rational number, do you have to be an integer? If you are a rational number, do you have to be an integer? So let me just type that out for you so you can read that and you can see it. I think sometimes we can understand better whenever we're reading it. So if you are a rational number, must you be an integer? And the answer to that would be what? The answer to that is going to be no. You do not have to be an integer. Because what I want you guys to see is I want you to see all these different areas around the integers that contain all those different numbers that represent the irrational number or the rational number system. So therefore, no, this is a false statement. You do not have to be an integer in order to be a rational number. So think about those things as we're going through there. In today's homework, you're going to have a little bit of those. Irrational numbers, remember that's your pi. Natural numbers, meaning that's 1 all the way up to infinity, whatever you're thinking. An integer is going to be that 1, that -10, that -312, and so forth. And the rational numbers is going to give you your 1/3 and numbers like that. Now, you've seen this before. This is not a shock to you. Now, what's going to be new to you today is basically going to be figuring out an example of when these number systems are going to be used. So in your textbook, and actually, this is an example straight from there. It says, classify each variable according to the set of numbers that best describes its values. So what you're asked to do here is you're asked to read an example in life, and then you have to determine which number system out of these number systems right here on this chart is going to reflect the type of answer that you're going to get. An example of this is the cafeteria serves chili every Friday. So which set of numbers best describes the values for the number of people P who order chili? Now P are you people. You people are in the line waiting to get chili every Friday. So my question to you is, what type of number system represents the type of person that you are, the type of number that you are? So what you need to ask yourself is, are you an integer, meaning any positive, negative, whole number, including 0? Are you a natural number, meaning you can only count starting at 1? Are you a rational number, meaning you can be represented as a fraction? Are you irrational, meaning you go on forever and you never have any pattern? So with that said, the question I have for you is, first of all, can I have half of you? Can I say I'm serving 354.5 people today in school? The answer to that is obviously no. You cannot serve half of a person, because obviously you either serve one of you or none of you. So the answer to this is going to be which number system? Well, obviously this has to be the natural numbers, meaning I'm starting at 1 and I can physically count each and every one of you out there. So this one is a very easy one. I can only count natural numbers. How about the number of gallons of chili G sold? Well, G represents gallons. So let's think about whenever you go to the store and you are buying gallons. How do they come? Can you buy half a gallon? Can you buy a whole gallon? Can you buy 5 gallons? Okay, the answer to this is going to be you can buy partial gallons, meaning you can buy a fraction of a gallon. So can you tell me which number system represents a fraction of a gallon? Is that going to be real, irrational, rational, integers, or the natural numbers? And the answer to this is going to be your rational numbers, meaning it can be represented as a fraction. The next one is the number of students in your class. Well, this would be very similar to which example that I just talked about. If you said example A, meaning the chili example with the number of people serving, you're absolutely right, meaning you can't count half of a person. I can't have 2.5 kids. I either have a kid or I don't have a kid. So with that said, the number of students in your class is going to be a natural number, and again, we're going to have counting 1 all the way up to whatever. How about the area of a circle A found by using the formula A equals PR squared? What's that P represent? Well, I hope we all know what that is. That's actually going to be pi r squared. And why did it say PR squared? Well, if it gave you P, you weren't sure what was supposed to be there. That pi represents a very distinct number system. And what number system does that represent? Well, if we go back over here to the very first slide, I said an irrational number is a number that cannot be expressed as a fraction. These numbers are non-repeating decimals or roots. So pi and the square root of 2 would have been examples. So since we know pi is in that number system, isn't this a dead giveaway that this has to be known as the irrational number system? Meaning there is no rationale to it, it goes on forever, and it is what it is. Okay, number 4. The elevation E of various land points in the United States measured to the nearest foot. I'm measuring land points of elevation in the United States based upon the nearest foot. Will you tell me, how do you measure to the nearest foot? Is that going to be a never-ending decimal that doesn't have a pattern, such as the irrational number system? Well, I would say no, that wouldn't be a true statement. How about, would it be the rational number system, meaning I could represent the foot as a fraction? Well, the elevation E of various land points in the United States measured to the nearest foot. Well, if I'm measuring to the nearest foot, I'm either 5 foot or I'm 6 foot. I'm either 3 foot or I'm 2 foot, right? So with that said, can I have a fraction of a foot? If it's measuring it to the nearest foot, what number system does that have to be in? Well, there's 2 options that many of you are going between right now, and that's going to be the rational number system and the natural number system. Now, some of you may even be considering the integers. We often leave the integers out in something like this because we're asking ourselves, well, can we have a negative? Well, absolutely you can have a negative. So my question to you, is it going to be integers, naturals, or rationals? I would say it's not rationals because you can't have a fraction of a foot. You're measuring to the nearest foot, so that means it's a rounding. So then it's going to be, would you accept the naturals or would you accept the integers? Well, I guess it depends upon how you view things. Are you saying above sea level or are you saying below sea level? And this is an elevation of various land points. So therefore, since it didn't predict, didn't tell you for sure, I would accept either one of those as an answer. Are we all good with that, understanding that the negative integers would represent below sea level, whereas the integers represent above sea level and be positive and only positive? Excellent. The next thing you need to know about is problem number 2, graphing numbers on the numbered line. What is the graph of the numbers -5/2, square root of 2, and 2.6? Now this book has a tendency to insult your intelligence at several points in it, so if this is below you, I apologize, but it's always good review for you to understand where numbers fall on the number line and how to represent them. So without grabbing a calculator, which is exactly where I want you guys to go with this, is you need to figure out where these numbers would fall according to the value 0 on the number line. Well, 2.6 is extremely easy to do. 1, 2, 3. 2.6 is going to be somewhere right in here, right? It's positive, it's in between 2 and 3. We can easily see it on the number line. -2.5 is going to be a little bit easier, a little bit harder for you to see, because you have to actually say what is -2.5, -5/2. -5/2, I already gave you the answer because I wasn't thinking, is -2.5. Okay, so with that said, we can come over here, and that's going to give you your -5/2. The next thing you don't know is where's the square root of 2? Well, I want you to go back over to here and square your numbers. So 1 squared is 1, 2 squared is going to be, not 2, but 4. Sorry about that. 3 squared is 9, and 4 squared is 16. Which means if I'm going to take the square root of these numbers, it's going to give me 1. If I take the square root of 4, it's going to give me 2. If I take the square root of 9, it's going to give me 3. And if I take the square root of 16, it's going to give me 4. So with that said, the square root of 1 is very close to is 1. The square root of 2 we don't know. The square root of 3 we don't know. But the square root of 4 we know is 2. So with that said, 3, or the square root of 2, would be close to what value? Is it closer to 1 or is it closer to 2? Well, obviously it's closer to the value 1, so it's just a little bit above 1, which can put me right about here. And you can estimate that, and that's without using a calculator, which is exactly what I need you guys to all get used to doing. So this is the number line that I would be expecting you guys to use and how you would graph them. Again, I don't mean to insult your intelligence, so this is above you. I'm really sorry. You're just going to have to get over the anger. Order real numbers. How do you take the square root of 50 and 8.8 compare? Whenever I say how do you compare these two, I'm talking about these lovely little symbols here. Can anybody tell me what those two symbols are? Well, if you're immediately doing the alligator, please stop doing the alligator. I don't want you guys to think alligator. I want you guys to think money. So what I want you to do is I want you to put the lovely little number line here for you to see. If you put 0 in the middle, all the numbers to the right of it are greater. So therefore this symbol means greater than. And all the numbers to the left of it pointing down mean that you're greater in debt, which means it's less than what you have, meaning the less than symbol, which is a wonderful, wonderful thing to remember. So with that said, I'm going to come back over here and we're going to discuss how do we compare these two values. So I have the square root of 50 and I have 8.8, and I have to figure out which of these two symbols I'm going to put between them. In other words, is the square root of 50 larger than, meaning greater than, or is it less than the value 8.8? So what you have to go ahead and think about is your perfect squares, and we talked about them here just a little bit ago. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, and I'll stop there. So with that said, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. 7 squared is 49, 8 squared is 64. Now I can stop right there. Can anybody tell me why I can stop right there? Because what is the actual number that I am looking for? The number that I am looking for is going to be the value, the square root of 50. Do we all see that? So if I'm looking for the square root of 50, I want to know where did 50 fall. Well, 50 falls right in here. And is that going to be closer to 49 or is that going to be close to 50? It's going to be closer to 49, which means the square root of 49 is going to be very, very close to the value 7. Which means if this is approximately wavy equal sign 7, is 7 less than or greater than 8.8? Well, that means 7 is less than 8.8, so therefore I can easily put in there that the square root of 50 is going to be less than 8.8. And this is exactly how I expect you to do it on your homework this evening too. So the square root of 50 is less than 8.8. Okay, and again, you guys are going to be able to do that tomorrow. We'll talk about things like this and answer any questions that you have. Now this right here is going to be the section that you guys are going to hate, and it's going to blow your mind again because you've been seeing these for how long? And I'm very, very sorry, but yes, it's back and you have to memorize it. So this is some of the worst part that you guys do on quizzes and tests because you refuse to sit down and actually memorize this. So the first thing you need to know is an axiom. An axiom is a statement that is accepted to be true without proof. So in other words, you can't say, but why? You have to say, oh, because it is. Okay? You just have to accept it because that's the way it is. So an axiom is a statement that's true accepted without proof. So given A, B, and C denote any real numbers, then the following is true. Now we have this old closure property. Now I'm going to tell you the kick to find the closure property. It's very simple. It's this right here, is a real number. It's saying, and we talked about this briefly earlier when we were doing the number systems, integers. Now I said if I take an integer 2 and I add another integer to it, 5, what is my outcome going to be? Well, 2 plus 5 is 7. So if 2 plus 5 is 7, what type of a number is that and what number system does it go? Well, 2 is an integer, 5 is an integer, so 7 has to be an integer. Well, that's saying if A is a real number and B is a real number, then the outcome of A plus B has to be a real number. Meaning if I take an irrational number and multiply it by an irrational number, it has to be an irrational number. I can't have any other product. So very easy kicker is just know is a real number. It literally says it just like that. Now, the associative property. Please, 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 when you abbreviate associative, make it ASSOC. No cussing at me in class. I would greatly appreciate that. I know you think it's funny, but it's really not. Associative property, please make sure that you're putting addition at the end of it, or associative property, and make sure you're putting an X for multiplication at the end of it. Because these are two distinct properties. One goes with addition, one goes with multiplication, but more importantly, what you need to know is that the order stays the same. This is so important. I wrote order saying the. That's not very nice, is it? Order stays the same. Very, 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 very important. Because you are going to mess this one up and confuse it with the lovely property of closure. Closure, the order does not stay the same. What I need you to notice here is that I have the value 2, 3, 4 on the left side of the parentheses. And on the right side of the parentheses and equal sign, I have 2, 3, 4. Notice the order stayed the same. What moved were my parentheses in the associative property. Now, if you come over here to your lovely little closure property, I have that the order stays the same, that the order moves. The order stays here also. But most importantly, on this one, the parentheses move. Okay, the order stays the same here. On the associative property, the order stays the same, the parentheses move. On the associative property, the order does not stay the same. Everything moves. Order changes. I sure wish my pen would work. See how I had the position of the 2 and the 5, and then what happens is I need another highlighter. Please forgive me. Need a different color. Then over here I have 5 and 2. The order totally swapped. So commutative property of addition and associative, the order changes. Associative, the order stays the same and the parentheses move. Now the next one that we need to talk about is distributive property. Distributive property, you guys have known this for I don't know how long. You guys do very well with it, so that should not be one that you struggle with. Okay, identity of addition and multiplication. Identity means whenever you look in the mirror, what are you trying to get back at you? You're trying to get yourself back. So what am I going to add to yourself to get yourself back? Well, that means 6 plus what value is equal to itself? Well, it has to be 0. And then 6 times what value is equal to 6? Well, that means it's 1. So every time you see a number multiplied by 1 or added to 0, it gives you itself back. That's the identity property. So identity deals with zeros and ones, but the most important thing is you're trying to get A back, whatever A was, whatever you started with. Okay? Now you're going to confuse identity and inverse because they both deal with zeros and ones. However, when it's the inverse, you're trying to cancel yourself out. And that's the thing I need you to understand. When you're dealing with inverse, you're talking about canceling yourself out. So what am I going to add to 5 to cancel it out to give me 0? Well, if I owe somebody money, I have to add -5 to that. And the same thing happens if I have $10, what am I going to multiply that by to get 1 because I need to cancel it out, which means I need the reciprocal. Okay? So these are very, very important properties. Now, your homework tonight is basically going to be trying to identify these properties and figuring them out and finding out where they're at. Now, things to look for. The closure property says it is a real number. It says it right there. It can be a real number, it can be an integer, it can be a natural number. It's telling you it is a real number. Has something in there. The associative property, the order stays. Parentheses move. Commutative property, the order changes. Okay? Now, you need to be very, very, very careful with commutative property because you're going to see that it's going to look like you could have something like this. 2 plus 3 plus 4 is equal to 2 plus 4 plus 3. It is technically the commutative property because the 3 and the 4 swap positions. Okay? The parentheses did not move. This is technically the commutative property, so you need to be very, 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 very careful in identifying that. Again, if you see 0 or 1 in the statements, either the inverse or the identity. So with all of that said, this is your worksheet, so I'm going to go ahead and get you guys started on that. And I want you to basically tell me which property this is. So number 1, A times K times N is equal to AK times N. Well, my question to you is, first of all, did I distribute anything? Well, it's not the distributive property because I didn't multiply. So that means, did my order stay the same or did my order move? AKN, AKN. So did my order stay or change? My order stayed, which means that it cannot be the commutative properties because my order did not swap. So it has to be associative property. Now, which property is this? Is it associative of addition or associative of multiplication? Well, clearly they're multiplied together, so this is going to give you B, which is the multiplication. Now, the next one is going to be 6 parentheses m minus 4 is equal to 6m minus 24. How did I go from 6 to 6m? Well, I'm going to write that. And then how did they go from 6 to equal to 24? Well, they multiplied. So what property is that? Well, it's a dead giveaway. It has to be the distributive property. I'm sure many of you got that. Now, let's move on down to number 6. Number 6, -5 plus 5 equals 0. Now remember, I said whenever it comes down to your zeros and your ones, it's going to be 2 lovely properties. Is it the identity or is it the inverse? So when it equals 0, when you see a 0, you know it's going to be additive, either addition or additive inverse, identity of addition or additive inverse. So how do I know which one this is going to be? Well, did I get myself back, meaning I got my identity back? Or did I cancel myself out to get 0? If you said you canceled yourself out, you're absolutely right. So therefore, which property is that? It's going to be I for additive inverse. Very good. Now I want to go back up to number 5 here. So if we're looking at number 5 now, I have 8 plus r plus k equals 8 plus r plus k. Property is that. Did the order stay the same or did the order of the numbers change? 8rk, 8rk. Oh, the order stayed the same, right? So since the order stayed the same, they're attached by addition. What property has the order the same? You're saying associative property of addition. You are correct. Okay, moving on down here to number 11. What is that property? AB is equal to BA. AB is equal to BA. Did my order stay or did my order change? My order changed. Very good. So now what is that going to be? Are they attached by addition or multiplication? They're attached by multiplication, so I'm going to be looking for a multiplication one. So it's not that. It's not that. And it's not, has 0 and 1s or not, no 0 and 1s are in it. So you tell me, is it commutative or distributive property? Well, it's the commutative property, clearly, because the order is what changed. Okay, now, I want you to look down here at number 18. If x and y are integers, then x times y is an integer. What property is that? Dead giveaway. It is J. Very good for closure. All right, now you guys got a good head start on this. You guys need to make sure you focus on this. The back side of the worksheet is very simple. It follows exactly the directions that I gave you in the actual problems. What do I mean by that? I'm talking about these problems up here, ordering them, and also what number system does it represent, graphing them, and telling me what number system they represent. So tomorrow I'll answer any and all questions that you guys have over this. If you need help in class, please don't hesitate to come up and ask me. I hope this worked out great for you guys having it recorded this way.